Good morning, everybody. It's 11 o'clock, so we're going to get kicking off. Thanks for joining us, and thanks for giving up some of your day. We're going to try and keep this to 25 minutes, so if you've got any questions, if you could type them in to the text board on the right-hand side of the screen, that would be really helpful. But without further ado, I'm going to hand you over to young Stefan from AccelStor, and it's over to you, mate.
Thanks, Tony. Hi everyone, thank you for joining today. Really appreciate you taking the time out. I hope you're all enjoying the wonderful British summer weather today. So what I'm going to do today is take you through a bit about our technology, who we are as a company, and explain a bit about why RAID and technology that's based on spinning disk needs to be replaced. So primarily, AccelStor's aim is to create a new piece of technology that is built purely around all-flash. So a lot of vendors in the market that are all-flash vendors, they tend to focus on traditional technology that was designed for spinning disk, for example, as the title of this presentation says, RAID. So what I'm going to do is take you through a bit about how we've come around it, also what RAID is, and the advantages and disadvantages when it comes to using it with SSDs. So the other thing we're going to go through today is a bit about the worldwide market for SSDs and all-flash, about the technology itself, and then at the end a little bit about why us, why AccelStor. So the worldwide market for SSDs and all-flash arrays is growing massively. The first quarter of 2017, we've seen a $1.3 billion market, predicted to grow to $7 billion by the end of the year. That's from Delorio Group. We've also got in the EMEA market a 107% year-on-year growth for all-flash arrays. So the whole market in general is definitely moving towards all-flash over spinning disk. I've seen reports of spinning disks only having in the single-digit growth in the last 12 months. So it's very much moving towards this. So let's get into RAID and FlexRemap. RAID itself means redundant array of independent disks. Was designed primarily for uses with spinning disk. It was designed a very long time ago. The main advantage is you get bigger storage and you get some protection and you get the advantage of the performance of all of the hard drives within the group. So the main advantage here is if a drive fails when you've got a single drive, all your data's gone. With RAID, if you can lose one drive or sometimes two drives, sometimes half the drives, depending on which RAID group you're using, then you can still access the data. Now, the other advantage here is the capacity. So you get obviously an n times the number of hard drives in RAID 0 or -1 or -2 if you're using RAID 5 or 6. So traditionally, these reasons were there because people needed bulk storage. The issue is RAID itself is not an efficient algorithm when it comes to SSDs. SSDs work in a very, very different way to spinning disks. So what we wanted to do at AccelStor was create a new piece of technology, a new algorithm that essentially supersedes RAID when it comes to using it with SSDs. So the main thing what you can see here is without FlexRemap, we have an example showing 4 SSDs. Now at the bottom of the screen, you can see that it says how many times those drives have been written to. You can see that number is uneven. You can also see that the placement of the data within the SSDs is completely random. So there's no sense or reason for exactly where the data has been placed on the SSD. Now, if this was a spinning disk, that wouldn't be so much of an issue. But with SSDs, this has two faults. One of which is you're actually reducing the lifetime of SSDs 1 and 4 much faster than SSDs 2 and 3. Also, when you're only writing to the blocks on SSD 1 and SSD 4 more than the other two, you're only really utilizing the performance of those two drives, as opposed to utilizing all 4 equally. So this has two faults. One, the performance will not be the potential of all 4 disks being grouped together. And two, the drive lifetime will be reduced. So at AccelStor, we have a very different way of doing things. So with FlexRemap, the data is distributed evenly. And also, regardless of whether the data is coming into the system in a sequential way or in a random way, it is always written to the drive sequentially. So that means that block 0, page 1, 2, 3, and 4, which are at the top, those would be the first to be filled. Also, regardless of the block size, the system will break the blocks up into 4K blocks. So what that means is if you do a 4 KB random write, the performance would be very similar to what you would expect from a 4 KB sequential write if you were using our system. So this has two advantages. At the bottom you can see that each disk has been written to 18 times, so we have an equal level of wear across all the hard drives. It also means we have an equal level of performance across all drives as well. So it's a much more optimized workload for SSDs. So with traditional RAID, to put this into a graphical context when you look at it over a whole array, as you can see, different types of data have different sizes. So we've got SQL database, we've got some metadata for media, we've got mail, we've got SQL databases. Now, in normal RAID, you can see that these are distributed in a completely random manner. There's no rhyme or reason to the way it's placed on the disks. And you can see that the write count on the drives below, is in the graph, you can clearly see that it's not evenly spread across all the disks. So that means those drives have a much higher level of wear and are much more likely to fail earlier. With FlexRemap, regardless of the data size, because we're breaking it up into 4 KB blocks and writing it sequentially, we're able to distribute the data evenly across all of them. Now you'll notice at the top, just under where it says FlexRemap, you can see that it says Flash Memory Summit Best of Show. That is an award that we won in America, and it's probably the best award you can get as a flash vendor, to be honest. So we beat some very large tier 1 vendors for this, and we're very, very proud of having that award. So this exact technology is the reason we actually won that award. So to give you an idea of actual lifetime plausible numbers, this is exactly what would happen. So we took our chassis, it's one of our 8 base chassis, we installed normal Linux on it, and we used a RAID algorithm, which is done via MDADM, which is software-based RAID, and we ran a lifetime test. So to give you an example of how this test runs, we hit the drive permanently at a 100% 4 KB random write constantly for 30 days. When we do that, we can accurately and mathematically prove the lifetime of the drive and how long it's going to survive for. The reason for that is SSDs have a finite lifespan. They have a DWPD rating, which is the number of daily writes and deletes they can take. Using normal RAID, the average lifetime of one of these drives came down to 1.7 years. Now, obviously, that's in a 100% writing scenario. So this is slightly less than it would be in real world, because you would obviously have a mix. But when using FlexRemap, that jumps to 4.5 years. So we comfortably say that we guarantee the SSDs in our systems for 5 years. Now, if you were talking about other vendors that use things like traditional RAID technology that's been adapted for flash, this lifetime is still roughly the same. You will still suffer a shorter lifespan. Now, the key here, and this is what really makes the difference, is once a drive reaches the end of that serviceable lifespan, it's not a warranty replacement when it fails. The drive has reached the end of its serviceable life, therefore you would have to purchase new drives. So with a standard RAID system, you could be looking at, after 3 years, having to replace 2-3 drives, and then every couple of months you'll have rolling drives starting to go as the system starts failing through. For us, you would have the drives for 5 years, but because within our operating system we can accurately estimate the drive failure rate, we can give you a warning 8 months in advance that the drives are going to fail. So you can accurately plan either a replacement of the entire system after 5 years if you want to do a system refresh, or alternatively, you could look at replacing the SSDs one by one and rebuilding the array. But they are all leveled to around a 5-year lifespan. So if you compare the performance here, so this is a 4 KB random read metric, so you can see that we fully utilize the SSDs and we can beat people like NetApp in the market, also other vendors like Pure Storage and things like that. I have a more in-depth performance analysis a bit further down, but it just shows you, where we're punching out when it comes to the performance numbers. So with traditional RAID, it also has another downfall, which is if there is a RAID failure, if there is a drive failure, RAID continues to write to the group that has the failure. What that means is you're more likely to suffer a second drive failure because writes and deletes damage SSDs. Also, you're suffering when it comes to performance because the algorithm is having to rebuild the RAID array while it's being written to. So the CPU of the unit is slightly overloaded during that time. Now with FlexRemap, what happens if there's a drive failure? Sorry, I'll slightly rewind and just explain how we actually run the RAID. So we don't have, as I said, traditional RAID, but as you can see, we have SSD group 1 on the left, SSD group 2 on the right. Both act as a single namespace, so you can access it as a single group and you get the capacity of all of it. However, they act independently with a 1 disk redundancy per group. So in this example, SSD group 2 has suffered a failure. So what happens now is the system will intelligently redirect write operations to only go into SSD group 1. That means you get no issue with a second failed drive in group 2. Also, you get the full performance of group 1, therefore you have a very minimal drop in performance because simply you're just losing write SSDs. So the advantage of FlexRemap over traditional RAID here is twofold. One, you're less likely to suffer a secondary drive failure or even a third drive failure during the rebuild process, and two, you'll lose less performance while the drive is being rebuilt. Also, the hot spares kick in automatically, so the only time for an end user interaction with our system during a failure would be physically removing the failed drive and replacing it with a new one. That's the only interaction you need. So overall, the key message here is the advantage for FlexRemap is we're better for performance, we're better for SSD lifespan, and we're better for data protection. That's kind of our core message as a brand, and it's what FlexRemap was actually designed for. So our Vice President, Wei Fon, he was working within the Taiwanese government research department when he came up with this. So he was doing research into SSD technology, and he came up with what we now call FlexRemap while he was there. So this has actually been developed over the last 6 years as a core operating system, and is now growing massively into a fully featured product set with dual controller systems, with dual node systems, so you have a wide array of hardware and software features as well. I would also mention that software features such as replications, cloning, snapshotting, they're all completely free and included within the operating system. We also have no licensing at all, so there's no annual licensing fees. Everything is upfront and included within the system. So I want to talk about the benefits of all flash just in general. I've told you why our all flash is good, but the main reason for using all flash is for performance, but also there's things like cost saving you can have, and the ROI is quite incredible when you do make the change. So in a data center environment, 300,000 IOPS, which is enough to run probably around 50 or 70 VMs depending on the workload, maybe even 100 depending on what kind of workload you've got. That would require 750 10K SAS drives to be able to do that. So that's a massive 52U if you were using 4U 60-bay JBODs. So what you're able to do is if you replace that with SSDs, which have a much higher performance per drive, you would only need 1U with 8 SSDs to be able to achieve exactly the same level of performance when using AccelStor. Now, to put that into some kind of actual, tangible cost saving, this is taken from a Gartner report. So the average power reduction from moving from spinning disk over to SSDs is around 76%. So that means we have this massive power reduction. We have a space saving as well. So obviously U sizes, they cost money when you're renting data center space. Administration of having to manage that huge amount, you'd be able to have a much smaller amount of actual U space as well. And then maintenance. But the main thing here is the ROI is on average 5.4 months when you replace spinning disk for SSD. So lastly, why AccelStor? So we have a few different ways of approaching an all-flash solution. The first one is if you have a proprietary SSD, so you've got your own firmware on there, you have a proprietary hardware platform, and you have a proprietary controller. The advantage here is very high performance, but the cost is colossal because you have a massive overhead for the research and development into the whole platform as a whole. The second type is you use SAS SSDs with traditional RAID arrays, and then you have something like a dual controller system on there as well. So this is your likes of normal SAN vendors that are putting SSDs into something that was designed for spinning disk. So that means you have poor performance and the short lifespan of the SSDs. Now, at AccelStor, we've done this slightly differently. So we use standardized SSDs with no additional firmware. We also use SATA, not SAS SSDs as well, and we use standard server hardware. Now, what that means is we basically run, as a company, a software-defined model. So we actually develop software, which we then put on standardized hardware. So that means we get kind of the best of both. So we have a very high performance, but our cost much lower than the people at the bottom of this list. So to give you an idea of some of the people we're talking about here, the IBM flash storage would be the bottom module, Violin Memory, who are now unfortunately not with us, and then we've also got in the middle, NetApp and 3PAR. So these are the kind of people that we compete with on a day-to-day basis when it comes to both performance and capacities. So one of our kind of crowning achievements here is on the Storage Performance Council report, which you can view on their website if you go to the SPC website. We're ranked number 3 overall, but the the only people above us on that report are DataCore, which is software defined. So technically, we are actually the number 1 storage appliance for dollar per IOP on that report. If you go onto the website, you can actually see the full report. You can see exactly how the system was configured, how much it cost, everything. So if you want to look into that a bit further, then you can just go onto the SPC website. Now, this is a performance comparison. So some of these you'll notice aren't like for like. The reason for that is it's very hard to find some storage figures when it comes to people like Pure Storage or EMC. But what we've managed to get is some out there. So you can see our 4 KB random write on our P710, which is our latest system, is 700,000 IOPS at 4 KB random write. Now, you'll notice that there are some others down there, so Caminario, for example, they aren't able to come close to us. We've also got people like Pure Storage on there who are a market leader for all flash, but they only publish their 32K random read, so you can see just above it that we've done our own as well, and we still actually win. So the performance of our system is undoubtable. We're also willing to put our money where our mouth is. So if customers would like to test how our system performs, we're willing to provide proof of concept samples that people can test and see for themselves exactly how it works. So overall, what we've created is a system that is safe, it's secure, and we have a very high level of redundancy in all aspects to the system. So we have dual node systems that aren't dual controller. They actually have 2 systems side by side. That means that you aren't, at trouble if you have a backplane failure. You still have a full system that you can move over to. Also, if the array was to fail, you still have a second system. So this is a much more efficient route. In the bottom left, you can see, as I mentioned before, the way our data redundancy works. And on the right-hand side, we have the SSD wear leveling. So we increase the lifetime of these systems massively, and we make sure that we have the highest reliability that we can. So we see ourselves as kind of unbeatable when it comes to this technology. Some competitors, as I mentioned before, the ones that make proprietary hardware, proprietary software, they're very expensive. We have conventional competitors who are impractical, so the lifespan's too low, the low cost of TCO over the time. So as I mentioned, if you have 2 or 5 year periods, they may be cheap to begin with, but in the long run, they actually end up more expensive. So we think that our solution is overall the best when it comes to all flash arrays. Now, this is against our main competitors, so that's kind of quantifying the performance reports and everything else that I showed you before. So we beat them with that kind of ratio, so price performance, we got 40% on the competitors, on the performance itself as well. And then for data protection, because we have the full protection of 2 separate RAID arrays linked together, and also 2 complete units linked together as well, we believe that we have the best of all 3. So these are some of our technology partners. As I mentioned, we've got the awards at the top. So we were awarded in 2016 one of the most promising high-performance computing companies, one of the 10 most valuable IT solution providers, one of the 50 smartest companies, and I already mentioned the Flash Memory Summit and Storage Performance Council. When it comes to our technology partners, we work very closely with VMware. Our roadmap for VMware is much higher integration with them. Right now, we already have our own plugin that goes directly into vSphere, so you can manage our array directly from VMware. We've also got vVols on our map as well, and full integration for SRM. We already have the AAI. We're integrated with DataCore as well. We have specific SKUs that were designed for the tier 0 within DataCore. We're partnering with Intel for some of our new technology that's focused towards NVMe, Windows Server, OpenStack as well, and Tiger Technology are a very helpful partner for us going forward. So that's AccelStor in a nutshell. So from now, we've got any questions from people. I think we've had a couple come in.
Yes, Stefan, there's a couple come in on the notice board. One of them, you touched on the end there about NVMe. They just wondered, the question is about your roadmap around that and what your thoughts are in terms of the technology and the performance.
NVMe is undoubtedly kind of, for performance and latency, it's the way forward. So a lot of sectors like finance, banking, they're all looking at NVMe technology purely because it's lower latency. The main difference in NVMe and normal like SATA or SAS is that NVMe is actually it's a new protocol for talking to the disks, so it has less in the way, basically. So our roadmap for NVMe is substantial. So we actually already have an NVMe model out, which is called the P310, but we have an H310 around the corner, which is a dual node cluster version. We'll then be looking at NVMe over RDMA, which is definitely the future when it comes to these low latency things. And then we've got 25 gig and 100 gig technology coming as well. So we're actually investing quite a lot when it comes to NVMe.
Very impressive, very impressive. Another question that's come up on the board, Stefan, it's a green question really, and it's based on one of your slides talked about some green cost savings, power savings, and with the questions come back about, do you have any real world examples rather than the theoretical stuff?
Actually, yeah. So we've got a case study that's being released. It'll be on our website, I think, at the end of this week. And that is based around us replacing a spinning disk system. It's not 10K SAS, it is 7,200 RPM nearline SAS. But it was quite a large system. The reduction in power was actually even greater than what it said on the report there. So we had a 95% reduction in power, which is colossal. And we were also able to reduce them from a 6U system down to a 2U system for that. So we have a massive reduction in power saving. And then when it came down to performance, we also had an 85% increase in performance over their previous system as well. So that case study will be on the website at the end of the week.
Excellent, excellent. Thanks for that. And there aren't any other questions on the text board there, but what I'd like to do is say thanks, Stefan. We'll circulate this PowerPoint presentation to everybody, all the attendees. And we've rocked in 2 minutes early on time. Promised to keep it under 25 minutes. We're on 23. So once again, I'd like to thank you for giving up your time today. And thanks for joining us. And we'll circulate everything afterwards. So enjoy the rest of the day if you can, because it's raining just about everywhere. And thanks very much.